Ladies and gentlemen, welcome to the Ride Mechanic channel. How the heck are you doing today? Alright, today's video, I want to talk about F.L.Y over there at Phantasialand in Germany. So let's get right into it.
Now get ready. Here we go.
Alright, so a couple months ago, I was given the opportunity to make my way over from a business trip, and on the weekend while I was there in the Netherlands, I was able to drive out and go to Brühl, Germany, where Phantasialand is located. Now, this is an amazing park. It was definitely one of the bucket list parks I had to go to and visit, so it was super awesome. And while I was there, I got to go on F.L.Y. And F.L.Y is an absolutely amazing machine. I think just like a lot of stuff in Phantasialand, it's a mixture of awesome ride mixed with amazing theming that goes in the area. So I really think it's that 1-2 punch that makes everything just killer for it. So the ride is a roller coaster. Really genius, you figured that one out. Manufactured by Vekoma, it is their flying coaster. Now this is different from their previous revision flying coasters like Flying Dutchman and things like that. This is a true flying style underneath, and what makes it so unique is how it gets into that flying position. Now, unlike all their previous roller coasters, this flying coaster is an LSM launch. Now, in this particular video, I am not going to go into the LSM workings because I've already made videos on how LSM rides work. You can go check one of those out if you want to see the whole shebang about how the LSM system works. Not really going to go into that on this video. I'm more just sticking to the F.L.Y ride itself and how it works. Now, pretty impressive. It's got 1,236 meters of track, or 4,055 feet of track to go along. One of the things that's really hard to see and get into true appreciation for is actually how big the ride is. When you look at the ride, it's installed in such a tight footprint and it's so complex and there's so many things in the way, you can never actually see one particular full section of track. It's always hidden. The ride's always ducking in and out of something else. So you can never actually see the whole thing. There's construction photos, aerial shots of while the ride was being constructed, and you could tell that they put it in and they started constructing layer on top of layer on top of layer. I believe as you're walking around at the ground level, that's actually level 2, there's a level 1 below that, and then a level 3 and 4 above that, where different things are built. The ride crisscrosses itself so many times you can never tell which way the train is going, which way it's coming, and then it's also in between a hotel. So there's plenty of views from this from the hotel levels and everything else. Very scenic ride, very beautiful to photograph and to videotape. So it's one of the great things that I just stood around for a while just watching this ride run around. It is so amazing to look at. So let's start off with track and structure. Realistically, there's nothing too mind-bending around this track and structure. It's Vekoma's standard track setup they use. They use large pillar constructions all the way around. Everything is just buried inside of other things. There's pillars all over the place, but there's so many buildings and elements around there that they're kind of hard to really understand exactly how the whole thing is put together. But the actual construction of the ride is very basic. It's got multiple block segments. It's got 2 different launches. One is just a straight linear launch that marks the beginning of the ride, and the second one is more of a curved uphill launch towards the middle of the ride. So because it's got the 2 launches, you can say that there's at least 4, probably 5, maybe even 6 block zones to that thing. Because the track is so well hidden and there's so many things to it, it's hard to get a true concept of just how much there actually is in the area. But it's safe to say we could start at the station. That's 1 block. There's a turnaround outside of the station, and then advancement to the lift hill. That's a 2nd block. And then there's the lift hill itself. That's a 3rd block. The launch, that's a 4th block. Then you can say the mid launch, that's 5th. Then the brakes, that's 6. And then there's a unloading station, that is 7. And the reduction brakes, there's probably an 8th block in there as well, because I couldn't see it just being 1 full long continuous block. I could see it being 2 down in that area. So It's probably got 8 blocks in that system at least. If I think it's 8, it's probably more like 10. Honestly, not sure of how many train capacity that thing can run. I would imagine there's at least 3 trains in that work bay back there, though. Could be more, there could be 4. If we go back to the original theory of 2 blocks per train, has at least 8 blocks in the thing, so I could see, yeah, you could have 4 trains sitting on there, but probably like a lot of rides, they probably run about 3 trains through that thing. The drive system for the ride is linear synchronous motors. That's the way it works. That's the way it moves forward. It's a combination of linear synchronous motors and just a lot of drive kicker wheels that push the train around. Now, the majority of the ride in the slower sections, we're talking transport sections, off of brake runs, the things that are dividers between, are just motors with drive wheels on them. So the thing is pushed around a lot. Now, Vekoma and Phantasialand did a great job of coming together and making sure that thing absolutely cooks the entire time that it's operating. By that I mean there's not really a time when you get down and the ride slows down and you're just crawling from one section to the other like a lot of manufacturers do. You're moving at a pretty healthy speed the entire time. One of the things that's very interesting to watch is that when the train comes in the load station, it comes in at I would say, a running speed. Like a person running at full speed would probably match speed with that train as it comes in. And then right as it gets down to just about probably 3 meters away from where it needs to stop, it suddenly slows down and comes to a stop right there. So Vekoma did a great job with that and making sure that the throughput execution was met, I'm sure, by the park's demands. Throughput on that is 1,400 people per hour, I believe it was. So it's got a high throughput through it, which is pretty awesome. We need more rides with high throughput, that's for sure. Braking on the ride is also pretty standard. As it comes across and it goes through its main reduction areas, it uses magnetic brakes. And now this works in conjunction with the synchronous drive system. Eddy current brakes work great because it's already got magnets mounted all over the train. You simply just stick the reactive fins up into the track and the ride slows right down. Not a problem. The way Vekoma built their brakes is really nice too. From where you sit in the queue line, you can look down and see in one section where the brakes are, that you could see that the arms just pivot up and into the way of the train, which works great because if you have an actuator that gets stuck halfway, as soon as the train hits that brake fin, it will actually lift that actuator up into the track the rest of the way and cause the braking force to be applied. So it's a pretty fail-safe method of applying the brakes, but they are just standard eddy current brakes. Nothing to them. Pneumatic, both retraction and extension for both directions. So lots of air control on that thing. The rest of it is, like I said, it's mechanical drive motors. So you have AC frequency drive motors moving the train around with motor brakes on the end to hold it. Now, if this is your first time going to that park, riding that ride like it was mine, the other thing that is very hard to understand is just where the queue line goes. It is huge. The queue line wraps all the way around the ride until it comes back to the loading station, but you don't really have a good perspective of that. As far as I was concerned, it went around one little area and then went back. That's all I could see. But nope, you pretty much saw that ride from almost every vantage point, every angle. That queue line wrapped around everywhere. Must have the longest queue line in the entire park. That thing was huge, wrapped around just the entire ride, it seemed like. Now, one of the things that they've done right is the loading system to get people into the ride. I've always been a fan of if you're going to make everybody take everything off of their person before they get on the ride, then you need to provide free locker. Phantasialand did this in a very good way with F.L.Y. So it is like a lot of rides now, or a lot of rides being built now, where you have to go through a metal detector before you get on the ride. Because of this, Phantasialand is a strict, like, you can't film on their rides at all. I've heard people say, oh, we took video of it, and then the park contacted them and said, you need to take the video down because there's a strict no filming policy on there. That being said, there are some very early POV ride videos out there. I'm not going to show them because I understand the park's point of view. They don't want people bringing things on rides. They don't want things on that ride in particular since it crisscrosses the pathway so many times. And they just don't want things in people's hands or strapped onto them or in such a way where it could fall off. So I'm not really going to be showing that, but I got a couple screenshots of stuff that I used from those POV videos, where I did link the POV video in the description downstairs. So that is there if you want to go see the entire video. Perfectly fine. But so one of the things that's hard to tell on the POV videos is just the whole process getting up to it. So when you're in queue line and you get up towards the loading area, what they do is they split you off into these lockers where they're free lockers, but at the beginning of it, they give you a wristband to put around your wrist. Really cool idea. So it's a wristband with an RFID tag on the inside of it, and you basically take your wristband, you put it on you. You're not supposed to have anything else on you. You go through a metal detector, they check you. If you find anything else on you, they send you right back to your locker, put whatever it was away. Totally agree with that. So it's like, okay, they give you the wristband, which is color-coded. So that's a really cool concept by itself, because now they can allow multiple sets of lines into this area and people put stuff away. And then when you go through at the end and you're all done with your lockers, you have to go into a color-coded area to get back up to the load platform. So you can continue, it's basically an accumulator system. You could take a bunch of people from line, you could take 100 people, mix them all up inside there while people are putting their stuff away in lockers, and get them right back into the same exact line within, 20-ish people of where they were. So within a train length or so of where they were in the original line, which is really cool. So you go there, you use your wristband, push it against the locker opens up, you put all your stuff inside there, you push it closed, put your wristband up against it again, it locks the locker. Then you go get on the ride. Now, for all intents and purposes, I'll just skip right to the end. When you come back on the other side, you use that wristband on the opposite side of the locker, because they're pass-through style. Good job. To open that locker up. If you forget where your locker is, there is a little screen over there on the wall. It's really nice. You just go up and you put your wristband to it, and it will tell you, oh, by the way, you're locker 418. So it's like, okay, so you go back over to locker 418, unlock it. Only downside to that I could see is that, well, if you dropped that thing somewhere, then there's a good chance somebody else in the park could pick it up and then go retrieve stuff. But the locker area is heavily guarded, which means that it's one way in, one way out. You can't come backwards through there. So I imagine that if I lost my wristband, they would eventually come to me and I eventually go to them and they say, okay, it was this, my stuff was here in locker 418. What was in your locker? It was my phone, my keys, and I could prove it's my phone by opening it up with my combo. Say, open 418, say, open your phone, put my combo in, yep, all this is your stuff, bye. And then later on, somebody comes up and says, hey, I forgot my stuff in the locker. First of all, the fact that you got out of the ride with the wristband, they're like, you didn't forget your stuff, because nobody gets out of that area with that wristband at all. It doesn't happen. Secondly, that wristband was reported lost about 15 minutes ago, so not the case. And they could just turn those people away. Go away, go away. We don't want you here anymore. So really cool system. So it's an accumulator system that allows you to get in, put your stuff away, and comfortably get back in line and not feel like you lost your position and you've gotten set back 4 or 5 trains now. Super cool. So as you go up to the queue line, you get in there, you get to the load station. These vehicles come screaming in unloaded because they've already been unloaded in the next section. So they come in unloaded and it's up against the wall. Now, this is a really interesting concept because we've seen Vekoma's earlier revision of the flying coaster, which was the Flying Dutchman model, where it was 4 across, and it's basically like a B&M invert, but it's upside down. You sit down on your seats, you get all buckled up, and the thing goes backwards and tilts you where you're face up. And then you go up the lift hill, it rolls you over, you're in the flying position. We know B&M style, which is where you sit underneath the track, and you sit down, load in, and then they pull the pods backwards, and then at that point you're face down going forward. Well, Vekoma had this ingenious system that they put on this ride, and this is really where the bread and butter of the system is, and it's super cool because it was such a simple move on their ingenuity that they didn't really have to do any of that crazy stuff that they did before with the Flying Dutchman model, and they didn't have to do anything else crazy like B&M does with their model. And I'm like saying, well, what's that mean, crazy? Why is that? Like all the sensors and everything else needed to lock and unlock those pods and pull it back up into position, external stuff in the track that's needed to move the equipment on one way. It's got to be monitored and everything. Vekoma went around all of that, and they like, this is going to be slick. Now, this was also the point in the video where I want to say, like, if you're in the, if you're in the U.S. here, Hollywood Studios for Disney, they're going to be opening up that Monsters Incorporated ride. It's speculated right now that this particular Vekoma system is also going to be doing the loading, unloading of the new Monsters Incorporated ride. It could not. I mean, it's a cool concept when it comes to that sort of thing, but I honestly don't understand why they would use it other than just to make it, I don't know, maybe it makes the unloading easier, but I don't quite understand that one. But I saw some modeling, some rendition of it, and it looks like the same thing. So let's get into the nitty-gritty of the train. All right, so the first thing you notice is that when you come up there, if there's not a train in the station, the first thing you'll notice is that the track that the train rides on is on the wall. Now, for a lot of us, that is a very big head scratcher. It's like, why is the track on the wall? We're used to the track being overhead. We're used to the track being on the ground. Why is it on the wall? Because the train comes in sideways and the vehicle is, you're sitting sideways. So like I am sitting in this chair right now, if you can imagine just a rail behind me, and essentially, well, the wheel carrier in this position would be correct because the rail would be behind me horizontally like that, one towards the top and one towards the bottom, and my seat, just like I am right now, would be attached to the vehicle, which is literally sideways. It's hanging on the side of the wall. That is the concept. That is the what the heck. That is the oh my gosh. Because the vehicle doesn't need that elaborated, like, oh, we're going to have to take the people down or we're going to have to lift them up into it. It doesn't have to do that because of the way the track is positioned. So really amazing. The track is behind you. Okay, so you go in, you sit down. It's a normal seat. You pull, basically, it's a vest restraint down, and that latches down, ratchets down on top of you. It is very, very similar to a B&M Flyer. Okay, it's got the same exact type of mechanics on it. It's got a vest. It's got the pin locking on the side where it comes down. So it's mechanically latched into place, hydraulically assisted, mechanically latched. It's safe. Now, on the B&M, what they used is two little tiny metal flaps that came out to pin your ankles into the ride. But what Vekoma did is they actually used these like a C-shaped looking device, and it hangs out to the side like this. So pretty ingenious. You would take your ankles and you put them into this, and as you push it forward, they rotate and lock in. And then once your ankles are in there, you have another piece above it, and your ankles are in the middle, so your ankles can't come out of it. And all it takes is a little cam to unlock that component, and then you just pull your legs right back out of the side. Really simple, really effective. I believe there's less to fail in that assembly. By fail, I just mean like less to go wrong, less to mechanically bind up, less maintenance involved than there is in the B&M system. I believe the Vekoma system kind of came out ahead in that deal, especially when it comes to pinning your legs in. All right, so you get in, they close everything down. The ride restraint system says, yes, my restraint is closed. No more power is going to the cylinders. Everything is in the lock position. You get the dispatch. They give the all clear, dispatch the train, and the train instantly takes off to the right. You accelerate around the corner quickly. So from there, you basically go around the corner and you do a 180-degree turn and you come back down this little hallway. Now, around that 180-degree corner, this is the transfer assembly where they actually bring new trains or take trains off the track. So this piece where you're going down this long hallway in the back is actually quite necessary when it comes to putting trains away, both putting trains on and off the track. That's where you would basically use the accumulator to put them on and off. I imagine you would say, okay, I'm going to bring this train in and it's going to go into the station. And then I'm going to roll the track back over, advance the one in the station into that long hallway, roll the track back over again, bring the next train forward in there, and then you could probably advance trains from there to keep them moving onto the track. Now, once you're done with that long hallway where you've essentially paralleled the loading station, you're now going to make about a 90-degree bend, probably a little bit more than that. And now you're going to go up a 30-degree lift hill. Now, the 30-degree lift hill is necessary because, like I said at the beginning, this ride is set on so many different levels. Well, where you load is that level 1. It's at the very bottom, but technically it's kind of underground. I mean, it's people are above you at that point. So you have to go up past that point where people are and up a little bit higher to get to where the launch track is. Now, that's after you come up that 30-degree lift hill, you make another 90-degree bend, and then that's where the magic happens. When you make that 90-degree bend, the seat that you're in rotates 90 degrees to the right. So if you look at me the way I am right now, it rotates 90 degrees this way to the right. And the track, remember I said the track is behind you, the track rotates, because you're facing this way, so the track rotates 90 degrees at the same time. So you have both the left rotation of the track and you have the 90-degree rotation of the seats. So if you can imagine your seats here, like this, if you're sitting facing this way, seats go like this, and then track goes like this. And now you're in the flying position. Does that make sense? Maybe a little CAD would help here. All right, we'll use some CAD design to help us out here. So basically the train kind of looks like you have a wheel carrier here, 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 and here. And the train is kind of looks like an arrowhead as it goes out. About like that. Let's cut that up. Okay, so basically this is what your chassis looks like. It's sitting this way when you're loading, and you're sitting on here, but you're facing this way. And there's two seats right next to each other. So you need something like this. Okay, so here's the way the vehicle sits unloading. You can see my mechanically engineered people sitting there, probably to the ASTM F.24 standard. Anyways, so it sits right there, and basically it pivots right where my fingers are. Oh, let's not do this. Hold on. I found when working with CAD the easiest way to make a hole in the center of something is to use tools to cut holes. It makes the cleanest hole in it. Alright. I need glue. Never fails. Go for super glue and ended up not having any. But little strips of command hooks will probably work just fine. Right in the right-ish order. Hopefully this works. Well, we're about to find out if it works. Yeah, yeah, sure, that'll work. All right. Yay! So here's my people. So as you get in, you sit down in the vehicle's like this. Makes that 180-degree turn, goes around the corner, goes up the 30-degree lift hill. Now, this is kind of uncomfortable to sit there like this, but those sneaky guys, they actually have a bus bar running up the lift hill that allows the vehicle to also pivot 30 degrees so it actually stays level as you go up there. And then once you go over, you simply just, now, from this position, as you go into the launch position, all the seats do is rotate like that. That's all it does. It just goes from here to here. That's it. Nothing more. But while that's happening, your vehicle goes from here to here. Does that make sense? So it's going in from the sitting position into the flying position. So what that looks like, do it both at the same time, is it looks like this. Does that make sense? You want to see it again? Sorry. Maybe I can get it up a little bit higher so you can see underneath it just a hair. All right, so it goes from this position here, goes to that position just like that. That's all it is. And now you're in the flying position. See, now the track is overhead going this way, and you're on the bottom having fun doing what you want to do. Now it goes the entire ride like that, and then when it comes back down into the brake run, it slows down. It slows down, 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 and then right when it comes back over, it does the exact same thing in reverse. So, in 2 steps, it takes your vehicle and puts those tracks on the back wall again by turning the vehicle like this. At the same time it does that, it takes your seats that you're sitting in and rotates them back around like that. And so when you come in off the track, one shot again, you're coming into the ride like this, and then it goes, okay, you go into the brake run, and right as soon as you come out of the main reduction brakes, it simply just turns like that. Pretty simple, right? That's it. And then you're back into the sitting position, and you're moving back into the next position, and you go around to the unload station, restraints unlock, you get off. Now, how do they do the turning motion? Well, that is one of the big things. It's also one of the things we know probably the least amount because it's Vekoma's new system. Now, one thing I'm able to find out, so a lot of rides like to use battery packs and things like that on there to lock, unlock, the stuff like that. But manufacturers don't like to leave the lock and unlock of restraints up to the vehicle. I.e., like when you have a vehicle that has rotation and power on it, like Guardians of the Galaxy, Cosmic Rewind, there's a handful of them out there, like the new Fast and the Furious. Those things will have their own onboard power to move the vehicle around, do audio, sometimes visual effects. Like Vekoma's tilt coasters, they have lighting effects that go down the side of the train. Well, there's a battery on board to do all that stuff, multiple batteries on board to do all that stuff. But they don't do that with the restraint system because they don't want the train out there somewhere. The PLC goes haywire and says, hey, let's open the restraints, or let's do that, which there's mechanical safeties involved. There's relays that have to pull in out of series and things like that. But they don't want that possibility, so they don't give the vehicle that option. That means the lock and unlock command for restraints is given via bus bars. That means bus bar is a pickup that runs along the back side of the train. It's contacts, they're energized with power. So F.L.Y is no different. In the braking area, in the lift area where it goes up that 30-degree lift hill, in the station, everywhere, there is a set of bus bars that run behind the vehicle. The vehicle comes in and it picks up on those bus bars. Now, the vehicle has a bunch of different pickups in the back, and I'm going to guess at their orientation on there. I'm going to say that the top 2 are your ASI bus and power, which means it's lower 24 volts control voltage. But the 2 wires that feed it are also the 2 wires that use to talk to the rest of the ride. We'll get into that in a second. The 3 wires below it are going to be phase wires. They're going to be UV and W, RS and T, L1, L2, L3, whatever you want to call it. Those are going to be your 3-phase wires going down there, and that's necessary for the spin and rotational motor, basically, to right the vehicle back upright at the end. So what happens is that you come into these runs and you slow down to a stop, and then the vehicle's brushes pick back up. When those brushes pick back up on board the train, the processor and drive controller light up. They go through a very quick boot up sequence, which is very fast. There's probably actually batteries on board to keep those living, so they don't have to go through the entire process. But startup is quick. So as soon as they get power, they start up and they start looking for a signal. Now, this is where the ride has to communicate to do two commands, basically. One is to unlock the rotation. By the rotation, I mean your seats. It can't just do this at any point in time. There's a lock on it. The second is to actually rotate. So those are the two commands that it's looking for, and the ride does that via its proximity sensors that go down the line. It says, okay, the vehicle's in the right spot, go ahead and unlock, rotate 90 degrees. Now, those rotate commands and stuff are probably just positions stored inside the drive. Like, the ride is not telling the drive to go to rotate clockwise for 13 seconds, nothing like that. The ride simply just tells the processor on the train to tell the rotation drive to go to position 1. Then the processor on the train says, okay, it talks with the drive and says, hey, we're going to go to position 1 once it's safe. What's it safe? What does that mean? All right, in the back, on the back side, where the rotational bearing is, there is a large, basically a jaw behind there that is interlocked with itself. Now, the exact description of that jaw is kind of up for grabs on here. Think of it as like a gear, something like that, and then it's got the mating surface on the other side. Well, the way that works is it pulls apart the two pieces and allows one to rotate, and then it locks back inside of it. So this prevents the vehicle from getting stranded outside of its position. So if it rotates out of position, then stops, the drive will communicate that it had a fault, that it never made it to that position. The sensors will also line up and say, hey, by the way, these seats are out of position. So what will happen is that as you come up into that launch area, you're coming up there, and it goes to turn 90 degrees, and then right here at this position, the drive faults, and it sticks it right there. And you'll go up into that launch position, and it will advance the train forward, and then as soon as it gets to a spot, the processor will look for the all clear from everything, and each coach will report back and say, I'm good, I'm good, I'm good, I'm good. But then coach number, we'll just call it number 3. Coach 3 says, nope, my drive is faulted, and my seats are out of position. So before the LSM system gets the command to go ready, so the LSM system is sitting in not ready, basically it's off. Before it gets that command to go ready, the PLC says, whoa, stop everything, and it shuts the whole thing down, throws out a catastrophic fault to the ride, and stops all motion on the ride. It's like, nope, we got something out of position. Now, might not stop all motion if the block system is set up in such a way to where the vehicles are running at a lower capacity to where there is an open block at the end of the brake run. It would probably continue to run vehicles through to get everybody off the ride, but you might have a vehicle that's getting ready for dispatch, it will stop. You might have a vehicle in the unload station, it will stop, and then there's probably room for that other vehicle in the brakes. I would imagine, where I was talking about the block segments earlier, you have the main reduction brake through the 90-degree turn. That's where this guy would come through here and basically rotate like that. So it'll go through that 90-degree turn. Then once that train is sitting horizontal again and everybody's back upright, that's probably the end of the block segment right there, to where it's like, okay, train's in, everything's good, people have rotated. The only time it wouldn't be is if you had a power failure. Then none of that stuff would work. So now we have this vehicle sitting up there that's in the flying position where it is not mechanically locked in. In order for the lock on the ride to work, it's basically got an open face that has indentations on it. Now what's up for grabs is how many indentations are on it. In my mind, there would be it's just a gear. So a whole bunch of indentations where it could pull away, basically like this, where it would pull away, and then it could rotate, and then lock back into place. Now, part of me says, no, it wouldn't be that, because you don't really have a need but for 3 positions. You're going to have basically position 1, position 2, and then position 3. And then, so the ride, as you dispatch, you're in position 1, going up that 30-degree lift hill, you're going to go up, and it's going to tilt at the same time. That's position 2. And then as it rotates, you're going to go position 3. And as it comes back down, you're going to go back to position 1 again. I don't see a need for more than essentially 3 positions, which in my mind would be 6 notches in that thing. But it could just be an open face gear sitting there. Those are easy to get a hold of sometimes, but Vekoma engineered this from the ground up. They filed a patent on it. I read the entire patent. You can go find the patent yourself and read it. They've built the patent in such a way where they said this is our design, nobody can copy it, and at the same time where you can get enthusiasts, and myself included, out there reading through the patent, still like, all right, well, that still doesn't show me the nuts and bolts of how they did it, but I have the general concept. 2 teeth assemblies basically matching together like that. When the command is given to rotate, an electromagnetic coil behind one pulls one tooth assembly apart. And then the vehicle is allowed to rotate, and then that coil is allowed to drop back in. Now, one of the things necessary here is that is a very large electromagnetic coil inside there, which means it needs a lot of current. Now, normally on these rides, when you run your bus voltage, 24 volts DC typically used, that's used for pretty much everything low power on the ride. But in this case, I'm going to say since we have 3-phase power available for the rotational motor, it's a little tiny spin motor that sits on the back and does the rotation like that. Since we have that 3-phase power available there, I'm going to say we're going to take 2 phases from that power, and that is going to go through an onboard transformer, which is going to then go down to that electromagnetic coil, after fuses, of course. We're going to fuse it, and then that's going to go to the coil. So, in sequence, what we do is we come into the ride, we power up the bus bar system on the back of the train, and the coils for the bus bars, or the pickups for the bus bars, are right towards the front of the train in most cases. The way Vekoma's done it is that it looks like every 2 coaches that come together, there's a set of brushes that pick up right there. It's really sneaky. I got some off-ride footage, and I screenshotted right as the train was coming up slow. I believe it was up by the hotel, and you could see the yellow pickup brushes sitting up on top of the train. There's a set that go forward to the first coach and a set that go backwards to the second coach, and it's like that all the way down. So they power up, they go, okay, I got power. The processor comes alive inside the coach, because when you open up those connection boxes on the side, there's processors and drives, coils, all sorts of stuff inside those boxes. The processor comes alive, and it goes, okay, I'm here, what am I doing? Once the train goes past a certain point on the track, the control system says, okay, go ahead and rotate to your correct position. Now, it might give it the command to say, yeah, go to your position A. It might talk to the train to do that. Or, a little bit harder, a little bit older technology, but it could work this way, it uses a set of pickup tags on the track. Like it would use a proximity, or like a metal flag on the track. But I couldn't see those anywhere. I couldn't see anything like that. So more than likely, the processor talks to the train and says, hey, once you've flagged this proximity sensor, once the train goes by and flags this prox, I'm going to tell coach 1 to go to position 1. And then it flags it again. That means coach 2 goes to position 1. Flag it again, coach 3 go to position 1, and so on and so forth. So each time as it goes down, it rotates and rotates like that. All right, so as it makes that flag, it says, okay, coach, we'll call this 1, go to position 1. So coach number 1 internally says, okay, I have all my power, I have everything I need, my system is good. Remember, it's been powered up for a second or 2 now. And it goes, okay, energize the electromagnetic coil. So it brings the power, pulls those teeth away. Proximity sensors verify, yes, in fact, those teeth have been pulled away, and it's in its retracted position now. And then it goes, okay, drive, move to position 1. The drive clicks on and then starts to rotate. The drive says, I've gone to my position 1. Proximity sensors on the coach itself also pick up and say, yes, I can verify 2 different locations. That is position 1. And then the PLC says, okay, turn off the electromagnetic coil. It locks back again. And then the PLC says, okay, I can confirm to the ride controller now that my pod assembly is in position 1, my drive is turned off, my electromagnetic coil is turned off, and my feedback says it is in fact in position number 1. It's good. All that happens within just a couple of seconds of power up. It's a really quick process. The whole system was designed around that process. Super cool system, right? Like, I thought it was amazing. All right, so I found a video of F.L.Y actually doing testing at the factory. I went to the owner of the video and asked permission to show this, and the owner granted me permission to show this video. So we'll have a look at this video, but it's very, very cool. There's lots of interesting things to point out on this video. It's done at Vekoma's factory. It's not at Phantasialand yet. It's actually in the factory, and they're just doing very rough revision 0 prototype stuff here. So this is not the final product. It's not what it ended up to be. They did use parts from this video to make the ride, but this isn't actually the thing that it's going to be. They just wanted to get kind of the big major components together and do some testing. So let's take a look at that video. All right, this is the vehicle back at the factory testing. Here comes the last seats right here. There's actually seats mounted on it, and there it rotates into position. Now this is, I'm pretty sure this is all done off a battery pack for this particular version. It's not done off a bus rail just because there's no bus rail in this area. The final version, I believe, works off of all bus rail, because that makes the most sense. You don't have to power it up. You don't have to worry about the batteries going dead while the train is running. If somebody corrects me from the park, that's perfectly fine. I could be wrong about stuff. That's not a big deal. But on the final version, like to make this last corner, this would be the launch up here that it's going to, you basically would have to put bus rail along this entire outside corner, which is doable. It's easy. It's just mounting brackets and stuff and adjustments. Same thing for that. I could see if they use bus rail for the majority of it just to charge, and those actual transitions are running off of battery. So, you know, basically you're charging it the whole time, and then you basically stop charging it and let it transition, and then go through, and then it has to transition again, and then you continue to charge it after that. I could see that happening, but yeah, so either they're charging the entire thing or using it only for feedback. But the new system, the system that's actually installed on the ride, has much more bus to it than this prototype 0 does out at the factory. This is Vekoma's factory. Very cool. Watch it go around. That was really cool, right? I thought that video was so cool when I saw it. I was just like, wow, that's incredible. I like how, you know, the earlier concept was the whole thing was going to be battery operated, or maybe they just had to make it battery operated due to, you know, they didn't want to put a bunch of bus rails and stuff out there on the track. Now, granted, they spent a ton of money to make that assembly at the plant to test everything out. I mean, you're paying millions and millions of dollars for a roller coaster. It needs to be tested to make sure it can kind of work before you supply it to your end user. But bus rails are, again, really, really, really expensive, and they're very sensitive too. They don't like to be in harsh environments. So I completely understand if they just didn't want to install bus rails for that particular instance because it was going to be too much for the track. Unfortunately for this, I couldn't find any information on the little motor that actually drives the units from one side to the other. I know it's basically a ring and pinion gear on the backside, or a ring and spur gear back there with a motor that runs it Three-phase power makes the most sense because it's something that can just kick in, rotate it one direction, and then stop. Plenty of torque and everything else that it needs for a very small motor. DC is a little bit safer to use in that scenario, but the motor has to be really big, adds a lot of weight, and then the bus rail pickups need to have a lot of current going through them to drive that motor as well. So it's kind of like better in one hand, but not in the other. Safety trade-off and power versus weight, all that other stuff. So when it comes to the LSMs on the track, it looks like it's just a standard Pro Lim. They're basically Intrasys stators. It's their slimline stators that they pretty much put out on most everything out there. The one thing that I was really confused about when I was standing in line and I was looking at these little tiny, it's like a little bar that runs right along the outside. And I was like, what is that? And I was standing in line trying to figure out what it was. And I'm like, is that to help support the stators? No, that doesn't, because in some pictures I could see the bolts holding the stators on. And then it finally dawned on me, it's like, oh, that's the cooling system. I was like, oh, okay, all right, yeah. There was another picture I found where that rail on the outside, that looks like it's just got a bunch of bolts through it all the way down. At one point, you can actually see there's a break in the rail, and you can actually see ductwork coming down to that rail for the cooling fans on top, because those things need cold air blown on the stators all times to keep the thing nice and cool. So the system runs good. So what do you think about the video? I thought this was a really super interesting thing, and it's a new thing. It's kind of that groundbreaking, like, wow, what they did wasn't crazy. So they were able to do it swiftly and easily. And at the same time, it's just so mind-bending to just say, well, just take the track and turn it on its side. And then, take the track and turn it on its side, and then we'll just turn the people right side up. It's like, Vekoma, how'd you think about that? Like, that is crazy to think of. The most I've ever come up with was, like a situation like this, but where the vehicle has to stop vertical. And, you would load people in this level, this level, this level, this level. That's all I was able to think of. What are you guys' thoughts on this? Do you have any information to add? I don't think I'm leaving anything out of this, but you never know. Sometimes I do. Let me know. You can always comment downstairs. You can also email me at ryantheridermechanic@yahoo.com. And I think that's it for this video. All right. Stay off the air gates. Bye.